Welcome back to the channel. I hope you guys are doing really great. So we will see today's daily challenge on LeetCode and we will try to solve this together. So today's challenge is not at all a very difficult one. It is a very doable and you have a simple O of n solution which we will discuss, and let's see and try to understand the problem statement at first. So what we will do is that we are given an array nums of n integers and your task is to find the maximum value of k for which there exists two adjacent subarrays of length k each. Okay, so you have been given a integer array nums and you need to find two adjacent subarrays of length k each such that both the subarrays are strictly increasing. Okay, and you need to find the maximum such value of k, and I hope you already understood what is the meaning of the adjacent subarrays of length k. Okay, so if there are two indices a and b, then b must be equals to a plus k, which means that from a to a plus k minus 1 there should be k elements, and b to b, and they should be strictly increasing. Okay, so I hope it is very simple. So basically what they want us to do is that they have been given an array num, so you need to find two subarrays. So let's say this is a subarray and this is a subarray, two adjacent subarrays such that the numbers in them are both strictly increasing. Let's say 5, 7, 9, and let's say here it is something like 6, 12, 22, something like this. Okay, and you see here what will be the value of k. K will be here 3 because this is length 3 and this is also of length 3. So you need to find the value of the largest such k. Okay, so the largest such k is what you need to find out, and yeah, that is all actually you need to do. So yeah, can you do it in a single pass without much thinking about some other approaches or any complicated approaches in a simple O of n solution? So I will try uh, advise you to think in that way. So what you can do, you see, you can definitely have the one variable as which is iterating in the current place. Okay, so let's say we can have one, and while this number with, let's say, this array of I is greater than array of I minus 1, while the current number is greater than the previous number, we can do a len plus plus. Okay, so which will tell us that in the current subarray, in the current increasing subarray, which what is my length. Okay, now I should also have a previous, which will tell me that in my previous subarray, which is the one which is having the increasing number and having the length, what is the length of that. Okay, so basically previous stores, it also stores the previous length, previous value of len. Okay, so that's what it stores. So yeah, you can have these two variables and you can just simply iterate. Okay, so what can you do? uh, then you can just simply maximize your k and return k. So what do I mean by it? Let's say you can start from, let's say, I equals to 1 and go all the way till n minus 1. Okay, both inclusive, and you can just check that if array of I is greater than array of I minus 1, you can have len plus plus. Okay, so otherwise you have a breakpoint. Okay, so you see, otherwise you are going to have a breakpoint. So what are you going to write in the breakpoint? You see, you can write something to maximize the value of your k. Let's say maximum of k comma something. You can try to maximize the value of k, and you should definitely then update your previous value to the current length, because in the next iteration the current length will be the previous length, and you can just do len equal to 1 because the length get resets to 1. Okay, so yeah, that you can do easily. And what do you need to place here, over here, what do you need to place, that becomes the point. Okay, so you see, let's say this is some portion of the array which was strictly increasing. Okay, and this was also an adjacent portion of the array which was also, let's say, strictly increasing. Okay, so I will consider this as a small one, and this is also strictly increasing. Okay, So let's say when you have this, when you are lying on this particular breakpoint and you are lying on this particular number, what you are actually doing is that you are updating your k. So what will be your k? You see, this is your previous value, okay, right now, and this is your len value. Now you see, you definitely can, these two arrays should be of the same length k. Okay, I need to find k. If you remember what we needed to do is that we need to find the largest k, and they both should have the same length and adjacent value. Now you see that they are both having the adjacent values. Okay, that you can guarantee, because in that way only you are updating your answers, but you cannot guarantee that they are of the same length. So how can you make them of the same length? So let's say this has a length of 8 and this has a length of 5, you can just do minimum of 8 comma 5. Okay, or what else you could have done? You could have also done something like this. So you see, you can just simply write here in this, you can could have written minimum of previous comma length. I hope you do understand what I am trying to do. Okay, what I am actually doing, you could have done. Or you see, there could have been also another case, not only always the minimum. Let's say previous has something like this, okay, and you see there is a breakpoint here and the length is something like this. Okay, it is a very large one and you are currently lying on this breakpoint. So this was the length which you calculated. This is the breakpoint, and at this breakpoint you are just going to set your len to 1 and your previous to len also, but just before that you need to update. So what will you update here? You see, you could have told me that in this is the whole increasing part, right? But this len by 2 portion is also increasing, and the next first len by 2 and the second len by 2 portion is also increasing. And you see here in this case, len by 2 can also be greater than this previous value. So let's say previous was something like 5 and this whole thing, this whole length is something like 20. So len by 2 is 10, len by 2 is 10. So this is also a strictly increasing and increasing subarrays, and you see these also satisfies all the conditions, right? Like these both are subarrays. There need not be any actual breakpoint, right? There need not be any actual breakpoint. So this is also of length 10 and this is also of length 10. They are both strictly increasing. They are both adjacent. So you could have done this also. So what can you place? What can you place as the third argument is that len by 2. This is all. Okay, so this is all. So what you need to do is that you need to simply calculate the maximum value of all these. Okay, so yeah, you have it, and that will be your answer. You can just simply return k. Okay, so instead of returning k, you could have written something, this whole thing. You could have written this whole thing again and just return it. Okay, so I hope it is very simple and easy to understand. There should not be any difficulty in this. If you are still having any doubt, you just tell me in which portion you do have a doubt. Okay, so it's very simple. I can just recap this whole thing once. You see that there can be two strictly increasing portions of the array where there is a breakpoint. Okay, you see 9 and 6 are actually decreasing, but these two arrays are adjacent which are increasing. So I try to do something like this. I try to keep increasing my length as long as I get an increasing portion. Otherwise, I assume that I get a breakpoint, and I could have made the previous and len updation in this manner. Is that we take the minimum of previous and len so that they are both of adjacent value. Okay, so you see, basically we are taking these two arrays where this is also 5 and this is also 5 in this case by taking the minimum, and by len by 2 I mean that let's say len is very large, even much larger than previous by 2, so large that even len by 2 is greater. So in that case there might be a possibility that len by 2 is also giving you some value, okay, some contributing to the maximum value. So you can just update your previous and len and return it. I hope this pseudocode is very simple enough, and you can, in whichever language you are using, you can easily code this out. Okay, there is no need to follow the remaining portion of the video. I guess you can easily understand this, and I am just, for the sake of purpose of doing and running this, I will just try to run this whole code once. Okay, in order to show you that this solution will also be accepted actually. So yeah, I could do this nums, if nums of I is, so I will just have all the previous value to be 0, len value is 1 and k value is 0. If nums is greater than nums I minus 1, what can I do? Simply increase len plus plus, otherwise you get a breakpoint. Okay, so this is nothing but a breakpoint, and in this breakpoint what you could do is that you could update your answer k. Okay, so max of k comma as I told you, minimum of previous comma len you could have done, and also len by 2 is what you should be looking for, and previous you can just initialize to n. You are just resetting the values now, getting it ready for the first next iteration, as you have already got a breakpoint. Len is reset to 1 and my current length become my previous length, and that is all, and it will be simple enough if you just return this whole thing again. Because what if my whole of the array is strictly increasing, then I would never reach into this else statement to the breakpoint, and in that case I need this length by 2. If my whole array is increasing, then half of my array can contribute to the those two sub arrays. Okay, half and half of the array if I place adjacently, they can contribute to it, and yeah, I could have done this also. So if I try to directly submit it, will it work? Let's see. So you see, we do get an accepted solution, and I don't know why it is not giving an optimal runtime. With the same code, I have got a better runtime complexity. So I hope, yeah, it varies a lot. If it varies a lot, you can just tell me what does the percentage bit shows, because you see, we are even not doing n log n. We are doing a simple O of n solution, and there is no difficulty in this, and it's a simple linear solution. So yeah, that's all, I guess. That's all from this video. We will meet you in the next video, and till then, thanks a lot.